Okay, so we're going to be simplifying radicals today. Now, what we've done before is we said, okay, square root of 80, like that's a little bit less than the square root of 81. The square root of 81 is 9. So this is like a little bit less than 9, like this is something like 8.9, right? And we could even go ahead and check that in our calculator. And we could put this in. And 8.9 is a good estimate, but notice this is called an irrational number. It's like this long number that doesn't end, it doesn't repeat. So the thing is, 8.9 is not an exact answer. So when we actually go to work with it in math, if we use 8.9, like our numbers are going to be a little bit off. Okay, so we do have a way of simplifying something like this though, and it's exact, it's not an estimate. Okay, and here's the rule that we use. If I have a number under here, I can break it into its factors. Okay, now look, this is an example, and this is a silly example because we know that the square root of 36 is 6, right? But look, here's another way of thinking about it. 36 is 9 times 4. So the square root of 36 is equal to the square root of 9 times the square root of 4. The square root of 9 is 3. The square root of 4 is 2. 3 times 2 is 6. Okay, now you're going to see 80 is not a perfect square. So it's not going to end up being just a number like this. Okay, I'm going to show you two different methods to do this. Method number one is faster, like way faster, okay? But here's the thing. Method number one is not going to always work for you. Method number two always works. So I want you to know both. I want you to be able to do the faster method when it works for you, but when it doesn't, I want you to have a second option, okay? And you're going to see what I mean by method number one's not always going to work for you. Method number one is to look for perfect squares. Here's what I mean. The perfect squares, and look, here's your reference sheet. So here's the numbers 2 through 10, and here are their squares. So all of these numbers are perfect squares, right? 4, the square root of 4 is 2, the square root of 9 is 3, the square root of 16 is 4, and so on. These numbers are called perfect squares. So we're going to look for these. Now, I've provided for you, and you're going to see why. Look, like this, 25 is a perfect square. 50 is not a perfect square, but it's 25 times 2. Okay, 75 is not a perfect square, but it's 25 times 3. Okay, you're going to see in a second why this is potentially really useful. All right, so here's what I'm going to do. I'm going to look for a perfect square. So 80 is the same as the square root of this times the square root of this. And what I'm doing is I'm factoring. Okay, now I'm not changing the number, I'm just breaking it down into a different situation. Now, here's what I mean about it's not always going to work. A perfect square that's a factor of 80 is 16. Maybe you didn't know that, but 16 times 5 is 80. Look, 16 times 5 is 80. Okay, so I can break this into the square root of 16 and the square root of 5. Well, what's the square root of 16? It's 4. It's just the number 4. So this is square root of 16 times the square root of 5. I just changed the square root of 16 to the number 4. The square root of 5, this number does not simplify. There's no factors, there's nothing that I can do to simplify this number farther. It's irrational. If I put square root of 5 here, it's this horrible decimal. There's nothing that I can do to simplify this, and so what I do is I just bring it down. So the square root of 80 is the same as 4 times the square root of 5. And you can say this as 4 root 5. Okay, 4 root 5. Okay, so here's the thing. I look at 80 and I see, oh, it's 16 times 5. But you probably look at 80 and you see, oh, that's 8 times 10. So maybe you don't catch that there's this perfect square here. That's okay. Look, watch what I'm going to do. If I don't look at the number and right away think, oh, it's this perfect square times some other number, then that's fine. What you do is you factor all the way down, okay, and you do what's called prime factor. When you get to a number you can't factor anymore, let's circle it. Okay, so like 2. The only factors of 2 are 2 and 1. I can't factor that anymore. 5, I can't factor that anymore. 8 is 4 times 2. I can't factor 2 anymore. I can keep going here. So 80, the square root of 80, is the same as, now watch, see how there's 4 2's? I'm going to list all the 2's together. And then I list the 5. So the square root of 80 is the same as this, okay? The square root of 80 was also the same as this. So everything I'm doing is equivalent here. Now, here's the thing. Watch what I'm going to do. I'm going to put the doubles in their own house. See how this double 2 went in its own house? This double 2 is coming in its own house. And then this single 5, the single stays in its own house as well. Let's see what happens here. This is 2 times 2, that's 4. And what's the square root of 4? Oh, it's 2. So this double 2, right, this square root of 2 times 2 becomes just 2. Let's think about why. You can think of it 2 ways. You can say, oh, this is the square root of 4, that equals 2. Or you can say, you know what this is? This is 2 squared and the square root. And squared and square root are inverses. They undo each other. So either way, I think, oh, the square root of 4 is 2. Or I think, oh, this number is squared and square rooted. So those undo each other, and I'm just left with 2. Same deal here. I'm just left with the number 2. And then here, remember, this one doesn't simplify. Okay, so I'm left with 2 times root 5. And that becomes 4 root 5. Okay, notice it's the same answer. 2 different methods, same answer. This one was way faster, but most of you probably don't look at 80 and think, oh, that's the square root of 16 times 5, right? It's just, you just don't think of it. So then you have to do this method. All right, let's see. 54. What are 2 numbers that multiply to 54? Okay, now look, what I'm looking for, I'm trying to think, what are perfect squares that multiply to 54? And you might know, oh, 54 is 9 times 6. So it's the square root of 9 times the square root of 6. What's the square root of 9? It's 3. The square root of 6 can't be simplified, right? Because I can factor it into 3 or 2, but there's nothing more to simplify. So this is the answer. Now, the other thing that might happen is you might look at 54 and think, oh, I can't think of anything that multiplies to 54. And then what you'll do is you'll reference here the divisibility rules. So let's see, a number is divisible by 2 if the last digit is even, like if it's 0, 2, 4, 6, or 8. So when I look at the number 54, I think, oh, that's an even number. I can just divide that by 2. So look, you might think, oh, I can't think of anything that divides by 54. I say, oh, it's an even number. Let's divide it by 2. And then you can even use your calculator and do 54 divided by 2. Oh, 27. Okay. And now 27. What's 27? Oh, 27 is 3 times 9. And then this is 3 and 3. So then the square root of 54 is the same as, look, I'm going to list all my doubles first. Any repeats, I'm going to list them together, okay? List them together so it's easier to group them. So I made sure I got all my circled numbers. Now look, this comes into a house by itself. These are singles, okay? There's not, like, see how there's 3 3s? These double 3s, they go into one house. The doubles go into one house, but the singles, they go into a different house, okay? Now they can go together, but they're singles, so these aren't going to simplify. What does this become? This is 3 times 3 is 9. The square root of 9 is 3, right? This 3 times 3 and the square root, that becomes just 1 3. Now in here, this doesn't simplify. There's no doubles here to simplify. 3 times 2 just becomes 6. Okay, again, you can see, same answer, just different methods. Okay, this one's tricky. This is a really big number. And so when you see a big number, especially like if it ends in 0, I right away want you thinking like, oh, if it ends in 0, that's divisible by 10, and then I just cross off the 0 and I get this, right? And so for a big number like this, you might end up having to factor. Now, what you also might see, and you're going to see I'm going to get kind of halfway here and have a problem, okay? But you'll see what happens. I look at this and I think, oh, you know what? When I see a number ending in 50, I think of 25. Like 25 is a perfect square, right? So this is the same as the square root of 25 times, make this neater, right? And the reason I think of this, I literally thought $4.50. Oh, I could have $4.50 in quarters. So I thought of 25, and then what's 450 divided by 25? It's 18. The thing is, I think to myself, ooh, 18. I feel like I can get a perfect square root of 18. And in fact, if you look, here's my perfect square 9. Look, 9 times 2 is 18. So I'm going to look out for these numbers, right? Because for example, if I see the number 50 and I want to simplify it, I'm going to say, oh, that's just 25, square root of 25 times square root of 2. And then I'll right away simplify, right? That'll become 5 root 2, right? That'll be the square root of 25 is 5 root 2, right? If I get this would be 5 root 3, right? I can just simplify that right away. Now, here, so I have this square root of 25 already. I'm going to bring it down. But the square root of 18, I can keep going because the square root of 18 is 9 times 2. Okay, so now, right, these things are all being multiplied together. And look, I want you to see 25 times 9 times 2 equals 450. So what I'm doing is I'm factoring, but I'm pulling out perfect squares specifically. So the square root of 25 is 5. The square root of 9 is 3. And then the square root of 2 can't be simplified. Okay, so this is 15 root 2. Now, if I was like super extra duper smart, I would have saw right away that this was the square root of 225 times the square root of 2, and I would have said, oh, that's just 15 root 2, of course. But, you know, that's not really how our brains work, right? Even though, obviously, that was faster, that's just unlikely that pops into your head. Now, look, this also works. Look, here it is. This is 3 and 3 and 5 and 5 and 2. And then what happens? We put the 3 times 3 in its own house, 5 times 5 in its own house, and the square root of 2 in its own house. Look, this is 3 times 3 is 9, square root of 9 is 3. 5 times 5 is 25, square root of 25 is 5. And then the square root of 2 can't be simplified. And again, I get 15 root 2. Okay? So again, same answer no matter how I break up that number.